and thanks everyone for joining us today. Welcome to the webcast on Amazon Web Services and the essentials for your organization. My name is Allie Hogan, and I'm joined by my colleague Amanda Kwan. Amanda and I are both business intelligence and analytics consultants here at Thorogood. You can also feel free to get in touch with us via our contact details on the screen if you wish to have a longer discussion about today's topic. In today's agenda, we have a few objectives that we hope to cover during this webcast. To begin, we will share an introduction to Thorogood. Then, we'll introduce the cloud, AWS, and review the value drivers for cloud business intelligence and analytics. We'll spend the majority of time today showing how AWS services can work together to achieve common business use cases around reporting and analytics. And finally, we'll share some considerations for getting started with the AWS cloud. For those of you who don't know Thorogood, we are an independent, global, professional services firm specializing in business intelligence and analytics strategies, solutions, and services with a keen focus on our customers. We are a global company with offices in New York, Philadelphia, London, Bangalore, Singapore, and Sao Paulo, Brazil. All of our consultants are recruited and trained in the same way to develop a unique mix of skills, blending business understanding in the form of industry and functional experience with a strong technical aptitude and a deep understanding of analytical tools and techniques. We offer a full range of BI and analytics services, including strategy and roadmaps, requirements, design, implementation, and training and support. Our clients typically span 4 data-rich verticals: consumer goods, pharmaceutical and health services, banking, and insurance. Our clients are some of the leading organizations in these sectors, and we take a lot of pride in the long-standing relationships we have fostered with some of the names you see here. In terms of the technologies we work with, we are an independent consulting firm, meaning we don't work with just one specific technology. We do, however, work and partner with many of the key players in the market in order to provide our clients with a solution that best suits their needs. We do partner with many of the leading cloud vendors, including Amazon Web Services, which we will be discussing in more detail today. Before we jump into the business use cases, let's first recap the key benefits of the cloud and introduce Amazon Web Services. So, cloud has been a popular buzzword among many IT and business professionals, and many organizations are working to define a strategy on how the cloud will impact their current systems and ways of working. So why have so many people agreed that the cloud is the way of the future? Well, we've outlined 10 key benefits of the cloud as we see it, but each business will likely value a few of these benefits more than others. For example, a sales team may be looking to use a cloud system to quickly and cost-effectively develop a tool to better manage their progress towards monthly sales targets, perhaps without being as dependent upon their internal IT department. Likewise, an IT department may be looking to increase scalability and improve resiliency for a heavily used point-of-sale system to improve reporting performance for end users and avoid system shutdowns during periods of office maintenance. Of course, your individual priorities and needs will be specific to your organization. Please do reach out to us if you're determining a cloud strategy and interested in our advice on what topics to consider. So while there are many cloud vendors in the marketplace, there's a few giants, a few smaller niche players. Amazon Web Services is really one of the key leaders in this space. AWS has a strong customer base, growing to over 1 million active customers in over 190 countries. In addition, in the recent analyst reviews by Gartner and Forrester, AWS is consistently ranked in the leader category. And finally, popular business intelligence software like Tableau Online, ClickSense Cloud, and Spotfire are all hosted on the AWS cloud environments. So, what does AWS entail? Well, here's a diagram of how Amazon organizes its product offerings. Behind each of these icons are a number of products or services that can be utilized as part of a solution. Actually, there are over 90 different products that are available. We won't be able to cover all of these products during today's webcast, but we will focus on the common pieces that would be used to achieve a few common business intelligence and analytics use cases. So, with that introduction, let's jump right into the details of how to use AWS with a few specific business use cases. The first use case we'll discuss today is how to approach a migration to AWS for an existing system. Let's say you have an existing system which stores your sales and target information with business logic to join your internal sales data to Nielsen market data and a front-end website where salespeople can enter and adjust their sales targets for the next month. This system is heavily utilized, especially at the end of the calendar month, and it's crucial for the website to always be available and up to date. Due to the importance of this system and some performance concerns from the users, IT has decided to migrate this to AWS for better resiliency and scalability. So, how do you get started? What should you do first? How do you efficiently execute this migration while continuing to achieve the business goals of that web application? Well, we've designed the following phased approach to quickly realize the benefits of the AWS cloud and then incrementally enhance the system by utilizing specialized AWS modules to provide new functionality. The initial phase is the transition to the cloud, focusing on leveraging the value of cloud computing and reducing dependency on the on-prem systems. As we've discussed, there are a variety of reasons why you should migrate existing systems to the cloud. However, when faced with this challenge, you'll want to avoid unnecessary work and focus on migrating the existing functionality into an AWS architecture. To fully recognize the benefits of the cloud, it's valuable to reuse as much of the existing code and functionality as possible to achieve this migration in a relatively short timeline to provide quick business value and resiliency. Then, the second phase is the enhancements phase, with an emphasis on converting existing functionality to AWS components for better performance, efficiency, and scalability. An analysis should be done to determine the pieces of functionality with the most impact and prioritize these in the conversion activity. Commonly, we also see our customers use this phase to incorporate feedback from business users and develop new pieces of functionality to add to the system. Thus, this phase can extend for a longer period of time, broken into shorter iterative sections. Now, we'll take a look at each of these phases in a bit more detail to outline the objectives and share a sample architecture to illustrate the potential AWS components that would be used in this migration. So first, let's discuss the transition phase to AWS. As I mentioned earlier, the purpose of this phase is to quickly realize some of the benefits of cloud computing by migrating an on-prem system into AWS. Therefore, in this architecture, we've chosen specific products that will allow us to reuse as much code as possible without removing any of the end-user functionality that the users know and love. For this migration, we'll need to consider three core components of the existing system: data storage, data manipulation, and the front-end reporting. And, as you might expect, there are AWS components that fit within each of these categories to achieve the same functionality. So, to start, we've chosen to use RDS as the storage database for our internal sales data, sales targets, and Nielsen data. This is a cloud-hosted relational database which is easy to write into and update records as required. Because we were migrating an existing Microsoft SQL system, we chose to run SQL on top of RDS. However, you can also choose to run RDS as an Oracle instance or a variety of other open-source databases. So, to make this migration a bit easier and easily move the existing data into the cloud, we recommend using AWS DMS, Data Migration Services. This securely moves all of the data from the existing system into any of the database platforms hosted in AWS. This service does not impact the source database, meaning the end users can still interact with the system while the migration is happening. Therefore, the business users are not impacted by this activity, and there is minimal downtime. So then, we need to figure out how to replicate the existing business logic where we join our internal sales data and external Nielsen data together. This is where we can be judicious about how much logic we redo. In this transition phase, we recommend using Amazon EC2 to host the existing packages that perform this data manipulation and transformation. Since we have a large amount of logic already defined, we'll want to avoid rewriting all of these functions. Therefore, in this specific example, we've spun up a VM using EC2 to host our ETL packages. Regardless of which tool you use, say Microsoft SSIS, Oracle, Informatica, or something else entirely, you can use this approach to migrate the logic into the AWS cloud. Also, if you are using Microsoft Analysis Services or Oracle for data modeling, this component can be hosted here in EC2 as well. Because one of our key drivers for this cloud migration is scalability, we'll want to use some functions within AWS to automatically provide this scalability. And the Lambda autoscaling function does exactly that. This function is event-based, meaning you can set different thresholds for CPU usage or date conditions where you would want to increase the computing power available in the system. For example, we know that this specific system is highly utilized during month-end activities by the salespeople. The Lambda autoscaling function is relatively straightforward to set up and will automatically dedicate more computing power during these times of heavy usage. Finally, we need to migrate the existing web page and connect it to the database and AWS environment. In AWS, we can use something called Elastic Beanstalk to host this front-end web application. Since our app was built using a .NET framework, we won't need to make many updates to the application for it to be used within this new AWS structure. Elastic Beanstalk can also work with a number of other different front-end apps, including ones built in Java, Python, or many open-source languages. From here, the business users can interact with the system and adjust their sales targets, just like they always did. They don't even need to know or realize that the system is now hosted in the AWS cloud, but can benefit from the improved performance during times of peak usage within the system. So, let's move on to talk about the second phase, the enhancements phase. Here, we'll look to add to the system that was built in the first phase, but include more pieces of functionality to better leverage the AWS cloud power of computing. As I mentioned earlier, there are a ton of products available in the AWS suite, but I'll walk through a few pieces that would provide valuable functionality to this existing system. First, for better scalability, resiliency, and reporting use cases, you should definitely consider the usage of Amazon Redshift. Redshift is a data store product similar to RDS, but better optimized for reporting and has additional out-of-the-box functionality. For example, Redshift is optimized to store a large amount of data in a scalable, cost-effective manner designed for reporting. If you expect your data volume to increase or have strong reporting requirements, Redshift should definitely be included in your architecture. Overall, Redshift makes it easier to query data stored in AWS, regardless of which product it's stored in, whether it's RDS, an S3 bucket, or something else entirely. Finally, there's better resiliency with AWS because the database will automatically take snapshots and backups of the data. Whereas you would need to build this custom in RDS, this feature is available natively in Redshift. We find that Redshift is one of the more popular products in AWS, and most business intelligence front-end tools like Tableau and Power BI can connect directly to this source. Second, based on the existing data manipulation packages, AWS Glue should be considered. Depending on the level of complexity and performance impact, certain packages should be prioritized to be redeveloped using Glue. This tool is optimized to work within the AWS components and efficiently manipulate data using straightforward functions and packages. While it might not be feasible to migrate all of your existing data packages into Glue, any new development should be considered to be done using Glue. For example, if you decide to perform new financial calculations on top of your sales data, it might make sense to use AWS Glue packages for this. Finally, it's worth considering how additional reporting requirements can be fulfilled. In this use case, the salespeople are relatively happy with the functionality of the web app where they manage their sales target information. However, they're constantly doing extracts from the tool to various ad hoc comparisons in Excel. They could really benefit from a streamlined reporting layer to see a consolidated view of sales versus competitor products from the Nielsen dataset and how they're progressing towards their sales targets. Within AWS, you can do some straightforward reporting in Amazon QuickSight, the front-end visualization product. However, as I mentioned earlier, most common business intelligence tools like Tableau can connect directly to AWS Redshift. This powerful pairing of Tableau and Redshift leverages the power of both tools for a cloud-based architecture in AWS with industry-leading visualizations and dashboards in Tableau. So, to summarize, this use case outlined an approach for migrating an existing system into AWS by combining a few AWS products for data storage, data manipulation, and front-end reporting. While there may be some nuances based on the complexity of your existing system, overall, this approach ensures that the migration happens in an efficient manner that is then enhanced with more AWS functionality. And so with that, I'll pass it over to Amanda Kwan, who will now discuss the next use case, building a data lake.
Thanks a lot, Allie. As you mentioned, the second business use case here is around building data lake. So we picked this use case because we're finding data lakes are becoming ever popular in the business intelligence space. The idea of housing all of your disparate data sources into a centralized repository opens up a number of possibilities with respect to analysis, analytics, reporting, and more. We're seeing more and more of our customers beginning to adopt data lake strategies over the past few years. Some are still finalizing the strategy. Others might already be a year or so down a, say, proof of concept route. You may be interested in hearing more about the how and why of data lakes, but we won't be deep diving into data lakes today. For the purpose of today's Amazon Web Services webcast, we'll take a common use case that we've seen with our customers wherein core components of the data lake strategy are built first, with a priority on providing end users access to as much data as possible and building out additional components over time. First, you'd look to identify those key data sets to bring to your data lake. High priority, heavily utilized data sets tend to be the first for ingestion. These can include, say, transactional data in SAP, Nielsen data in a SQL database, monthly targets in Excel files, or even sales data from Salesforce. With the technology and the data structure aside, you really need to ask yourself, what data does my business need? Next would be landing that data, and here we're recommending the use of an Amazon S3 bucket. Think of it as your landing zone. Nothing has been done to the data other than getting it from its source to that bucket. After that, you can use an Amazon Lambda function to look at that recently landed data, run some kind of validation quality control check, and do any expected data conversion. As Ali mentioned earlier, the Lambda functions are event-based, so as new data does come in, that Lambda function can be called to do this validation check. Once that has been completed, you can now drop your cleansed data to another Amazon S3 bucket. But let's take a quick step back. So we started with a bucket of raw data, and now we have a secondary bucket of cleansed and validated data. This is a common multi-stepped or multi-bucketed approach that we've seen our customers adopt, as it's important from a data governance perspective to provide end users access to not just one version of the truth, but the correct version of the truth. So generally speaking, companies will give power users access to this cleansed bucket of the lake as opposed to the raw bucket. So at this point in your data lake architecture, you can provide your users access to that cleansed part of the lake. However, while those data sets are cleansed, they are not necessarily mapped or joined together in ways that would be the most useful for your business. And that's the last part of this architecture. Another Lambda function will audit the newly updated or added cleansed files and provide the attribution with, say, master data or joining against other sources. In a perfect world, your organization across the board will look at data with the same dimensionality and attribution, but businesses are much more complex than that. Thus, you can imagine multiple data warehouses and relational databases to accommodate, for example, the data modeling needs of your different business units. So your sales function might look at source A and B with different dimensionality and granularity than, say, your marketing function. So here, we're using Redshift as our data warehouse, keeping data at a granular level, while Amazon RDS is used for more aggregate views for high query volumes to help boost performance. The Lambda function can push data direct to Redshift and RDS instances, and those two instances can speak directly to each other. Finally, a front-end reporting tool, say Microsoft's Power BI, can provide dashboarding and analysis powered by the RDS and Redshift instances. Note that while you're building out the different databases that could be specific to different business unit needs, your users can still be creating reports off of that cleansed data bucket. The data just won't be pre-joined or pre-attributed, so it would still require a bit of modeling work on the user side. This is a sample architecture for a foundational data lake built within AWS, but a data lake strategy is more than just providing one source of the truth. It's being able to also run analytics on top of the wealth of data that you've put into the lake. Our last business use case is around productionizing analytics. And what we'll do is actually build upon the foundational data lake that we've just discussed. Organizations are looking to drive their business into the analytics space to provide themselves an edge over competitors. To do so, companies are building out specific analytics practices, usually by hiring data scientists. These data scientists are primarily tasked to create algorithmic code, usually in R or SAS technologies. They usually, say, extract real data from source systems and then store them in Excel as a sample data set, and then develop and iterate on their code off of the sample data set. Once the algorithm has been defined, the data model tested, how do you take the code created by the data scientist and actually apply it to your full source data systems, and thus scaling it out for your enterprise organization? For this use case, we'll assume the company has a data lake architecture in place and is looking to build a productionized analytics system on top of it for fast and flexible deployment. So you've already built out your foundational data lake. You can utilize a technology like Docker to create a container with your R or SAS code and deploy the Docker image to Amazon's Elastic Beanstalk. As Ali mentioned earlier, Elastic Beanstalk is really great for deployments, and thus this can also allow you to deploy any APIs to allow the algorithm to call data and convert it as needed. Your end user can interact with, say, a dashboard embedded in a website from their browser, inputting parameters and seeing results in real time, powered by your data scientist's hard work. In this example, we're using a custom-built web application using the JavaScript framework called Angular. Seems pretty simple, right? There are complexities, obviously, as you dig a bit deeper, but hopefully this does give you a quick, pretty high-level sense of how just a few AWS tools can help you drive an analytics strategy forward. We walked through 3 common business use cases today, but there are several others I'm sure you're probably thinking about right now that you'd like to start tackling in your organization. So let's discuss some considerations for getting started. The decision to move toward a cloud-based solution depends on many individual factors for an organization. Some areas that you should consider before integration include data integration. So where are you going to keep your data? And if you need to combine cloud and on-premise data, how do you do it? Data privacy and security. Since the cloud is an inherently shared infrastructure, what precautions and certain measures will be taken to ensure the security of your data? Performance. Will the performance of my system and ability to move data be compromised? And finally, administration in terms of maintenance and configuration of cloud architectures. How will it be maintained and supported? If you're already set on the move to cloud and are looking for a few key components to get started with on AWS, let's review the tools we discussed here today. For data storage, we discussed the ability to use S3 as a structured and unstructured data repository, while RDS and Redshift were used for more traditional schema database and data warehousing tools. For computation, we had examples of running code and packages with EC2 and Lambda, while also using Glue for optimization. And for analytics, our web application and analytics code were deployed on Elastic Beanstalk, with additional analysis done in BI tools such as Tableau and Power BI. Thank you very much, everyone, for joining today's webcast. Please do reach out to Ali or I if you have any additional questions, and have a great rest of your day.